In the second part of activity 3.8, we'll use logs to solve exponential equations. Take a look at example 1. It says solve for x, and we're given 2 raised to the x equals 70. And they say, okay, well listen, 2 raised to the 6 is 64, and 2 raised to the 7 is 128. So 70 falls somewhere between 64 and 128. So we know our answer for x has to fall in between 6 and 7. But we need an exact number. So a way to handle this problem, we take our original equation, this 2 to the x equals 70, and we can take the log of both sides. So the log of 2 to the x equals the log of 70. And then we can use properties of logs to rewrite the left side of this equation, right? I can take the exponent and bring it in front of the log. So I have x times log base 10 of 2 equals log base 10 of 70. And then if I divide both sides by log base 10 of 2, I'm isolating x. And you end up with x equals 6.1293. Okay. So I want to take a look at a few practice problems. If you turn the page, we're given a practice problem. It says, use logarithms to solve each equation. Let's round to 4 decimal places. Show all steps and check your answer. Okay, so let's go ahead and give this one a shot. All right, so my step 1, I'm going to take the log of both sides. Okay, so you see I've taken the log of both sides. My next step will be to rewrite using properties of logs, where I can bring the x in front of my log. Okay, so you can see my step 1 was take the log of both sides. Step 2 is to rewrite using properties of logs. And step 3 is going to be isolate the variable. So if I divide both sides by log base 10 of 4, I should have x isolated. So you can see in step 3 I've divided both sides by log base 10 of 4. And the log base 10 of 4s will cancel out, leaving me with just x on the left side. And on the right side of the equal sign, I have log base 10 of 80 divided by log base 10 of 4, which we can do in our calculator. And you see our answer is 3.16096. And they do say we'll go 4 decimal places, so I'll round this to 3.1610. And here's my final answer. So let's try and solve question 12 2 ways. I'd like to solve it algebraically, and then after we do that, we're going to check our results by solving the same problem graphically. So here's my step 1. Step 2 will be to rewrite using properties of exponents. Step 3, we're going to try and isolate the variable by dividing both sides by log base 10 of 3. So in step 3, we notice we can cancel the log base 10 of 3's. And step 4 will be to completely isolate the variable. And we'll need our calculator to finish up. So I'll enter log base 10 of 5.5 divided by log base 10 of 3, and I'll press enter. So it looks like my answer is 1.5517 if we round to 4 decimal places. And there's our solution. So now I'd like to try and solve this same problem a second way. I'd like to graph both sides of my equal sign, or both sides of the equation, and we're really looking for what value of y will make the left side equal to the right side. If I put in this 1.5517 as my exponent, and actually really I'd want to use all the digits here, not round, I should get 5.5. If I substitute this entire number without rounding in for y, I should get 5.5 on the left side of my equal sign. So again, the question is really asking what value of y makes this statement true. It's this number down here. So graphically, if I graph the left side of my equal sign, so I press y equals, and that's going to be my 3 raised to the x. And for y2, I'm going to graph 5.5, and the intersection should be my solution. So let's just take a look at our window. Right, we'll go from 0 to 10 for the x, or for the domain. But for my y min and y max, well, the second line is going to be drawn at 5.5, right? There's going to be a straight line at 5.5. So I'm going to probably go to a number that's slightly bigger than 5.5. I'll try 10, 15. Okay, so I've graphed y1 is 3 to the x, y2 is the 5.5. I've changed my window. I'm going to press the graph key. And the intersection should be my solution. So if I press the second key and trace, because above trace it says calc, I want to calculate the intersection. Number 5 is intersection. It says first curve, all right, that's this y1, 3 raised to the x, that's this part. I'll press enter. It says second curve, that's that y2 equals 5.5, I'll press enter. Where do I think my answer is? Well, since there's only one intersection, it doesn't matter where I put this, but if there were multiple intersections, we'd have to move our cursor closest to the intersection that we're trying to find. I press enter. And it says, okay, Mike, at 1.5517286, that's where these two curves meet, which is what we have down here, 1.5517, rounded to 4 decimal places. So that's problem number 12, solved 2 ways, algebraically and graphically. Try number 13 2 ways, right? I want to graph number 13 and then I want to solve it algebraically. All right, so for 13 we have this 3 raised to the 1.5t equals 40. So I'm going to graph both sides of the equation. Okay, so here's the left side of my equation, 3 raised to the 1.5x. I put the exponent in parentheses. In this calculator, I do not have to, but if you have an older model of the TI, it's important to put the exponent in parentheses. The right side of the equal sign is 40. Now my window, for x min and max, I can still go 0 to 10, but for my y maximum, I have to be at least bigger than this 40, right? Because when I graph y2 equals 40, that's going to give me a straight line at 40, so my y max has to be bigger than 40. I don't know, I'll put in 60. Maybe you use 50, maybe you use 75. Any number bigger than 40 should work. I press graph. And my calculator's a little slow, but bear with me. There it is. And again, to get the intersection, I'm going to press the second key. I press trace to access this calc menu. I want to calculate my intersection, which is number 5. And first curve, I can press enter. It says second curve, I can press enter. Where do I think my answer is? I know it's somewhere around here. And it says, Mike, the answer to this is going to be 2.2385. So if I were to actually put this number in for t, I should get 40 on the left side of the equal sign. Remember, this problem is really saying what value of t will make the left side of my equal sign equal to the right side. Right? So if I put in this value for t, I'll get 40 on the left side. So now we know our answer is 2.385. Let's do this algebraically. Okay, so here's my step 1. I've taken the log of both sides. So step 2, I rewrite using properties of logs, right? I take the exponent, 1.5t, I place that in front of the log base 10 of 3. Now I want to isolate the t, so I'm going to divide everything by 1.5 times log base 10 of 3. So step 3, you can see I've divided everything by 1.5 times log base 10 of 3. I did that on both sides. And on the left side, things will cancel. The 1.5s will cancel, the log base 10 of 3 will cancel, leaving me with only the t on the left side. So step 4 will be to, isolate the variable and solve. So I can enter this into my calculator. And again, remember from when we graphed it, we know the answer should be 2.2385. So let's verify using our calculator. All right, so we're going to have log base 10 of 40 as my numerator. divided by, and I put the whole denominator in parentheses, 1.5 times log base 10 of 3. And then I close my parentheses. So I have 2 parentheses open, I have 2 closed, and we get that 2.2385. And that's what we received when we graphed it. So we know we did it correctly. And there's my solution.